There are many interesting places in our solar system, but the most amazing of them is Jupiter. The fifth planet of the solar system is named after the supreme Roman god of the sky. It was also known in the distant past under the name of another deity of ancient Greece, Zeus the Thunderer. Its monstrous gravity distorts the orbits of neighboring planets, and the opaque pall of clouds holds many secrets. Which ones? Today you and I are going to find out. We have to be well prepared, because the flight time from Earth to the gas giant will last about 600 days, during which we have to overcome 588 million kilometers of space. On the way we decide to get acquainted with the primary parameters of the planet, which are stored in the base of the ship. Jupiter is the largest inhabitant of our system, with a radius of nearly 70,000 kilometers, and could absorb all of its surrounding neighbors. And if we were to put a planet like ours inside it, we would need 1,300 more like it to fill the entire volume. Its colossal mass is equal to 318 Earths, which in turn is also more than all the planets of the solar system put together. In addition to being the largest planet, Jupiter is also the fastest planet in terms of rotation around its axis. A day here lasts about 10 hours, and one local year stretches for as many as 4,332 Earth days, which translates into almost 12 years. As we approach, we see 79 satellites orbiting the beige giant, forming their own planetary system in miniature. Most of them are quite small, and no more than 10 kilometers in diameter. But on their background particularly stand out four largest satellites called Io, Ganymede, Callisto, and Europa, which was discovered back in the 17th century by Galileo Galilei, so they are also known as Galilean satellites. Europa is a ball of ice, which plays with reflections in the sun. It causes quite a great interest in the scientific community, because it is assumed that in the waters hiding under its surface may flow a primitive form of life. Perhaps this is where the first space neighbors are hiding, which we will meet outside our planet, but unfortunately we have not been able to conduct a precise study of this aspect. The largest of these satellites is Ganymede. It even surpasses Mercury in size, and has its own magnetic field, as the full planets. The third satellite, Callisto, according to data obtained during the study, has a full ocean of liquid water under its surface. The last of its brethren, Io, in turn, is the owner of a large number of active volcanoes, heated by the tidal forces, and is geologically active, periodically spewing the contents of its bowels to the surface. On closer approach to the planet, we see the Jupiter ring system, 4 in total. They consist mainly of cosmic dust, so they are rather dim, and blend in with their surroundings. These rings are almost impossible to detect from the surface of the Earth, and even from here in space, they can be seen only from a certain angle, when the sun's rays are reflected when they meet them. On the gas giant itself, we see fast-moving clouds swirling around the planet, gaining speeds of over 600 kilometers per hour, and shooting lightning 1,000 times stronger than what we see on Earth. Out of this vast array of gas, there is a huge red spot, rotating counterclockwise in the southern hemisphere of the planet. This inconceivable size vortex with a diameter of 16,000 kilometers. For the first time it was discovered as far back as 1878, but during the observations it was noticed that it has decreased in size over time. But even now, our entire planet could fit inside it. Even if we wanted to, we can't land on the surface of the fifth planet, because it simply doesn't exist. You may have a question: will we be able to fly through Jupiter? To which scientists have received an answer while studying the gas giant, and we can get a detailed picture of events by simulating from our onboard computer. As we enter the atmosphere of molecular hydrogen with an admixture of helium, we can find that in its upper layers the pressure reaches the mark of 1 bar, and the temperature overboard is 145 degrees Celsius. But the deeper we plunge into the gas abyss, the higher they will become, increasing exponentially. Because of the incredible gravitational force acting on our ship there, It will develop a freefall speed of over 150 kilometers per hour. At the same time, we will be tossed from side to side and twisted by the Jupiterian winds. After a relatively short period of time, we will be met with a furious resistance of a denser layer of atmosphere. The force of the impact will be as if we hit a wall at full speed driving on a freeway. However, the fall itself will not be stopped. Continuing to rotate from side to side, and losing any orientation in the surrounding space, we will enter the layers of the atmosphere, where the ambient pressure will already exceed the Earth pressure by more than 100 times. And the density of the swirling clouds behind the window will completely hide the light coming from the sun, so we will be able to contemplate the blackness around us, similar to the greatest depths of the Earth's ocean. Continuing to fall into the bottomless depths of Jupiter, the increasing pressure will reach a point 1150 times higher than the previous one, and the inexorably rising temperature will heat up to several thousand degrees Celsius. Regardless of the enormously increased readings from our sensors, we would not have traversed even a third of the planet's space. By then we would surely be dead, but let's assume that with the help of unknown technology, we somehow miraculously managed to survive. Then we would be able to see how even deeper down the atmospheric hydrogen around us loses electrons and turns into metallic hydrogen, which is comparable in density to the Earth's rock. As we continue to fall into darkness, we approach the core of the planet, hidden somewhere deep beneath us. No human knows what it looks like, because it is not possible to determine its composition with modern technology. But according to theoretical calculations, its temperature reaches 24,000 degrees Celsius. And long before we encountered it, there would have been no trace of our ship. Ambient pressure would have crushed it into small pieces, and the ambient temperature would have melted the remnants, scattering the hull particles in clouds of gas. Such a disappointing outcome is clearly not in our plans, so we'd rather continue analyzing the planet from a distance from space. Having flown across the purple lines, we move to the North Pole of the giant. In this region we can see the beautiful blue polar lights spreading over the orange-beige clouds. It's similar to the Earth's northern lights, and is created by charged particles in the planet's magnetosphere, which in its turn is about 18,000 times stronger than the Earth's, and can deflect the solar wind at a distance of up to 6 million kilometers. The magnetic field of the planet produced by compressed hydrogen covers a huge area of space, and reaches even the orbit of Saturn. If it were possible to detect it with the naked eye, from the surface of our planet, we would see a giant ball in the sky, larger than the moon. The gravity of the gas monster affects the entire solar system, so that Jupiter constantly changes the orbits of comets passing by, sometimes mercilessly consuming them. Few people know, but in 1994 Jupiter actually saved mankind from a cosmic catastrophe. The huge comet Shoemaker-Levy 9, the size of our planet, flew into the solar system, and according to mathematical calculations, the probability of collision with the Earth was 95%. But the gravitational field of the fifth planet grabbed it, ripping it to pieces by its force, whereupon those changed route and fell inside the atmosphere of the gas giant. At the time, the astronomical community observed the event through telescopes in fascination. It was the first such cosmic event, involving a body of such dimensions ever to be observed live by humans. Scientists had seen fragments of the comet crashing into the gas clouds, and releasing an energy estimated to be comparable to the explosion of 300 million nuclear bombs. The debris in contact with the atmosphere shot out huge columns of flame, the largest of which rose to 3,000 kilometers above the upper layer. In addition to protection from space wanderers, Jupiterian gravity helps our planet to maintain a suitable for life rotation orbit around the Sun. So on Earth were formed favorable conditions for the emergence of biological life. So it turns out we are literally alive thanks to the existence of Jupiter. During the entire period of interplanetary exploration, the fifth planet has been visited by 9 space missions. The Galileo spacecraft was the first to orbit the gas giant in 1995. He transmitted to Earth information about the satellites of the planet, the composition of the atmosphere, as well as sent about 15,000 pictures of the space around it. Then in 2003 it fell into the atmosphere, melting in its upper layers. Then in 2016 the Juno Probe, also known as Juno, arrived at the giant, and is still carrying out its research. The station is studying the gravitational and magnetic fields. And in the future, scientists hope to bring it closer to the satellites of the planet, to get more accurate information about their structure. There is a hypothesis in the scientific community that Jupiter is not an established star. The composition of the gas giant is similar to the Sun, but it did not have enough mass to run in its hard thermonuclear reactions needed to turn into a full brown dwarf. Also, this idea is indirectly confirmed by the fact that almost all planetary systems have several stars rotating simultaneously. Because of this, our lone sun stands out against the background of its galactic neighbors. According to scientists' calculations, Jupiter is gradually shrinking and may never be able to light the fire of the luminary inside itself. After gathering all the necessary data, we fly around the largest planet in a circle, once again admiring the beautiful and incredibly dangerous swirling bands in its atmosphere. Beige shades of gas flow into brown and burgundy and white and back again. As we take one last look at their palette, we decide it's time to say goodbye to the ancient Roman deity and return to our planet. Thank you for exploring our universe with me.